Anyway, I think that quite often happens with the page rattling as well, isn't it? Right, let me just see if I'm capable of sharing the screen here. And so let me see. Share. That looks promising. Okay, now, so can you all see the title page? Hopefully you can. It's come up here as being shared. So what this is, this is it's definitely a work in progress, and this is me trying to sense check where I'm going, and what I'm endeavoring to do is build up a narrative, if you like, of what is the real challenge of being a data analyst, and this is all come really from our initial thoughts around the code of practice that the Office of Statistics Regulation has put forward, and they talk about how they seek to talk about trust, quality, and value is their group. But Honora Harris is talks about, rather than developing trust, which she quite wisely said might be it might be seen as gullibility. What you want to do is develop trustworthy people in general, and we're interested in trustworthy data analysts. And because if you just develop trust, which is what people keep talking about nowadays, you can end up trusting the wrong things. You can end up trusting fakes and things. So trust in itself is not necessarily a good thing. So Honora, now I've got to work out how to actually use my bit of kit. There we are. Oh, I haven't put the slides on, have I?
Yeah, we can see the slides.
Okay. There we are. So the way she relates it to is that trustworthiness is about having integrity, which is people accepting and expecting you to choose to do the right goals, not particularly for yourself, but with others, particularly your stakeholders in mind. So when you as an analyst goes and presents to somebody, the way it's going to help your career is not at the front of your mind. The second pillar of trustworthiness is that you're competent, so you can do what you say is the right thing and deliver it. And the third part of competence is that you will do it. And Nora O'Neill uses the framework of a teacher of your child, and that you may well think that she can teach maths, but you might not want her to drive the minibus, for example, is one of the examples. And that's trustworthiness is also related to the role that you're trying to play. And as I say, what I'm trying to do is then, and they relate it in the Office of Statistics Regulation to, they use the label trust. Quality is the competence pillar, and value is the reliability pillar. And then they give a list of things to do. I'm trying to relate that then to the context of an analyst. And forgive me if I'm become too Janet and John, if you like, and that what I've tried to go back to is what is the thing that data analysts are fundamentally trying to do, and I think what we're trying to do, which is different from others, is we're trying to say, what can we learn, and what insights might we derive from the process of counting, and I'm deliberately using that word counting because I get quite concerned that when we talk about data, And when we talk, and even more when we talk about big data and talk about IT, there's a sense of mystification. We're making things more mysterious at times. Now I am bringing in my ear one analyst from a project. This is a slight aside in that I associate this guy because he almost got me to do some work for Man United's first big global database, and it was one of those moral distinctions that I had to make. Would I actually do work to help a team I at the time thoroughly detested? Because as people have just been describing whether Liverpool and Manchester City's rivalry is of any consequence, I remember as an Arsenal fan the rivalry that Man United and Arsenal used to have. And only last weekend somebody asked me, I said, the difference is that Liverpool and Man City probably have more style, but Man United and Arsenal at the time definitely had more fire. But I go ahead. He said that where there's mystery, there's margin. And there is a sense in which being mysterious can, in certain circumstances, create a lot of power, and by that some value. And in a sense, that runs the risk of us becoming the if you like, the priesthood of our current society, that people just have to take what we say. And I don't think in the end that's a very healthy position to be with. But I also talk about counting because it differentiates from data used in operations, and where there really are products, where there really is a process where data's stitched together in order to deliver things, and to deliver things in our instance predominantly for the customers. And one of the things where I think that's quite an important distinction is that we can learn things by counting, which don't require us to have get all the connections right. So as we've already said this morning, we'll quite often be doing trials, we'll be doing things on snapshots. We don't need it to be truly functional, and we can work out whether it's potentially worth doing the operational process at the end of it by looking at a sample. And we learn by the counting if we know when that we've got the right illustration. So as an illustration, only earlier this week, I was looking at a process by which one of the clients is looking to understand their marketing attribution, and they've got a whole bunch of transactional data inside the system. They can look at when individuals register, and they're trying to then link that to their Google Analytics stream, and find that when they look at it, only a fraction, between 50 and 60% of their users actually can link between the Google Analytics and the transactional data. So they can only look at the funnel that Google Analytics allows on that 50%. Now, we could, on the one hand, spend a lot of time trying to then link the other 50%. But what an analyst will do, and the way we'll deal with it, is not to yet say, do we have to do that? But first say, if we only look at those that are matched, how much are we distorting the overall conclusion? What's the bias, and how distorted are we? So that's an illustration of quite how different we can be compared to IT and analytics. And I think that comes back to the point. And what I'm related to here is that we quickly move into different worlds, as I'll come to talk about in a minute, without necessarily realizing what we're doing, and certainly without other people realizing what we're doing. Before I go on to that, I just want to think a little bit more carefully about what we do when we count, because I think it's worth reminding ourselves, because we quickly do these things and assume various things. And I got involved in just considering some of the philosophy of counting, which is quite fascinating if you want to be particularly nerdy. But I think fundamentally, the really important thing is to begin with a count, and it's particularly the case when we're talking about understanding humans, is a count of a single act in time and space. And the important thing is that that count comes with that time and space for free. But we quickly forget it because we create this number that happened in time and space. And I think fundamentally that's why geography and the importance of geographically and spatial geotemporal data is so important in analytics, is because that count can only take place in a time and space. So all those interactions are there, whether we like it or not. And so often you see lots of people, particularly in the digital space, doing all sorts of analysis. And if all you do is attach that space to some almost quite crude geographical data, you suddenly give them insights that they've never seen before, and they sort of think you're amazing, and you've done something quite crude. And I think it comes from the fact that this sits behind it. It fundamentally also is about a process that traverses two different worlds, and I'll come to that in a bit. It traverses a physical act in the real world, which is the thing we're trying to solve in the process, and creating a number which sits in the number world. And numbers are fundamentally quite different from the things that we normally think about. They're dimensionless. They have one property about them, and that is that they can be ordered in terms of their size. They have no other property whatsoever, and that's the risk that we run whenever we think we can describe something in terms of accounts. Is it loses everything but one thing, and it has a fixed difference. 100, as I say here, the difference between 99 and 100 is the same as the difference between 2 and 1. We requires you to categorize. You have to know whether you're counting apples, you're counting oranges, or you're counting fruit. And I think that has really strong requirements for us to consider carefully how those categorizations take place. And I think you end up now in the sense that actually categorization at the moment has become quite political in the whole discussion about gender and sex and all the ways in which some people want to categorize those particular characteristics, and the way it's changed the census, for example, means that actually you've got to be careful when you're merging numbers together what it is you're actually combining. But we cannot get away from it because of this property that actually a number has only a single property. There's no other thing to do with it. And the other important element in the whole philosophy of counting is that you always need to make sure that when you count one thing, you don't recount it. So actually 3 really is 3 different things, or 3 different instances at different times, rather than the same thing being recounted. So it might sound a bit, and tell me if it sounds a bit nerdy, but I've gone back to really trying to think about how that remembering those things becomes quite an important thing, and tries to relate to what might happen next. So we've got to then think, and usually we don't think about these things at all, that actually once we imply a scale, even without thinking about it, when you think about a distribution, you're actually immediately saying that if I count 100 of these things, they're the same as counting one thing that's 100 times as big. And whatever scale you choose, that is something that you've chosen without thinking about it. And I'm suggesting that sometimes we ought to think about it. We then usually end up applying things on a linear scale, which says that everything has the same impact. We could apply things on a logarithmic scale, and you and we all know that actually logarithmic scales are often much safer ways of analyzing and are much more realistic in the way that they approach them. So the small numbers have a big effect. The more you get, the less you do. And interestingly, there's been some psychological studies that actually our minds are better at making logarithmic assessments, which makes me think that actually on the whole, a logarithmic scale is is quite often the thing that is more instinctive when people are thinking about things in the real world. And it's made me consider how valuable it is to consider some ancient ways of numbering, and one of the most crudest one is to say that you've got either nothing, you've got one thing, or you've got many things. And there are some languages which only consistently have that group. And you might say, well, that's immensely crude, but actually what it does do is it focuses on rare events, and actually in analysis that may well be the place where we should function, looking at unusual things that happen. It recognizes the fact that actually things can be highly correlated, whereas actually linear systems sort of assume that everything's independent. And it says that actually most things are going to be very shallow optimums. So I've used this scale quite often, particularly when you're looking at trying to identify credit. And I remember using it quite usefully, just as a recognition when you started to assess what was happening within autonomous cars. That when you heard of one death from an autonomous car, it could be anything. But actually, the fact that the second death from an autonomous car came quite soon after the news I heard about the first one was an indication that actually there was issues potentially with autonomous cars. And now as the years have gone on, you see that quite consistently, whilst the argument for autonomous cars is that they'll be safer than everybody else, quite consistently now the death rate connected with autonomous cars is about 3 times what it is for driver-driven cars. And this level has been quite consistent for quite a few years now. But this first, you get a clue that something's happening when the second thing turns up, and how quickly that second thing turns up is a quick clue on to whether something important might need considering. So that's the first element we want to do, and we've got to consider that data analysts are those people who become expert in learning from counting, and the fact that we're counting means that we work in 3 different worlds is my conjecture, and we're working in 3 different worlds. Sometimes I think we move into those 3 different worlds without really realizing it, and I think some of the stakeholders we work with won't even appreciate we've moved into these 3 different worlds. And these 3 different worlds are what I call Ilian, or it's the world in which numbers exist, the histogram at the top. It's the world on the right, which I call Digian, which is the place in which numbers are being translated into tech. And then the third world is the I haven't quite got the word, but it's the world of psychology and the ways in which we have to communicate, all of which are abstractions from the real world. But what's quite significant to me, and I'm going to dwell on this bit quite a while for a little bit, is that actually each of these different worlds have quite different instincts. So what do I mean by that? What I mean is that in principle, a number exists in perpetuity. Once you generate, the world of numbers is static. I mean, and that's what even back in the Greeks, they said that case. And actually the concept of being infinite occurs. You have infinite many things happening at the same time with a whole variety of different values. That's what a distribution is. It's allowing for the fact that actually multiple things can happen all at the same time and in the same instance and without interacting with each other. So for me, the fundamental instinct that you have when you're in that number world is that things are independent. And we know actually mathematically in the few solutions that you can get in that world, that actually you get the solutions virtually always by assuming at some level that the different variables in their model, the different numbers that you've counted, act independently of each other. And it's only that assumption that makes the solutions tractable. Now that has some great power, and the whole reason we work within that process is that those solutions are solvable and therefore have quite global and all-encompassing considerations, as long as the assumptions to make those things happen can be justified. So they create global solutions. They create solutions that describe large collective behavior. So that's the instinct. And by all means, I'd love other people to challenge the instincts that happen within that numerical world, or give me other lists. The second place that we operate is in this Drye, the tech space. Now, my experience here suggests that actually the instinct inside the tech space, it goes a little bit back to what we were talking about with Agile and BAU, but the instinct within digital space is to be reproducible, actually reuse, and it's not that the world in the digi space is always the same as it is in the numerical world, but actually we anticipate that we can move a bit of code and a bit of data from one system to another system, and it will give you the same number. It will give you the same output, and wherever you operate it, it will give you the same conclusion. And that's what I mean about that instinct for reproducibility. And we even know that actually the very process of writing very good code really, at that fundamental level, chooses the idea that actually you're going to use that code over and over again because it loads it into memory. At that fundamental level, it's constantly reusing stuff. And whilst the digital world doesn't enable us to have solutions that are as global as the numerical world, it does enable us to have somewhat more realistic simulations. And that, particularly now technology's got to where it is, we can apply interactions, simulations. We can do Monte Carlo calculations that are of equations that are not solvable in any particular way in the number world, but we will get them out. And as long as we set our random seed to the same number at the beginning of the process, we'll get the same number at the end of it. But what's different to the numerical world as well is that there are some quite severe constraints on the world. You and I all know that quite how the data is stored will affect not necessarily what you get, but even what answers you try and reach. So even to the extent that if my data is stored in columns, it's a columnar database, I will give it a different approach to if data's in a row-based structure, and I'll give it a different approach if I know I'm getting open text, which I've got a pre-screen, usually into either a columnar or a row-based structure. But there are, and that memory structure is again separated from the process in which I use my CPU to actually analyze the data. So there's a whole bunch of constraints, both on time and space, that constrain the types of solutions I can get. So I can become more particular than the solutions that you get in the number world, but I can't constrain and describe everything that's in the real world. So again, my instincts there about repeatability. And then the third world, this psychological world, is where we're probably most adapted. I mean, I suspect we're most adapted to what's happening in the real world. But there, what we're driven by is very much about the context. And this is where I go back to counts occur in a time and a space. Once they go into the number world, they forget the time and the space. But as in a psychological world, we instinctively remember it, and also when we're communicating to others, we have to be very aware not only of the solution that we found, but also the context in which we put it, and that comes out most when we're trying to do the. It particularly comes out when we're, for example, trying to do the visualization. I know we've had various talks at Doug just about the importance of design in the way we present data, just the idea that actually your eye goes, I think it's to the top left, and will traverse. So you put the most important things up in the top left. You might use just the use of different colors will make, if you use a red, it will generate a warning. If you use a blue, it will help calm people down. None of those things actually sit in the data, but we ideally, some of us will be, as we're communicating, will adopt those different types of and just know them, and they're all working because they're working on this interconnectivity and the narrative that comes along. So in a huge amount of difference to the number world, what we have in the real world, and particularly in our psychological world, is this idea of a narrative, a chain of events, rather than a single event on its own. And so what we're usually doing is looking at a whole array of interconnections, and definitely not independence. And so that, I think, at the fundamental our fundamental challenge is described by the way in which we have to move between these three different worlds, which pull us in different directions. And the more, to use an NLP phrase, the more we become consciously aware of this, at least for a while, the better we will overcome some of our unconscious bias. And I know, and I've got to admit, if you like, I myself have gone on quite a long journey. I remember when I first got into data analytics. I remember when I first built my the first segmentation, and actually it was, I think it was probably the first time I was invited along. It wasn't to Doug, it was actually to the MRS, the CGG group. It was when I first built a segmentation on the 2001 census data. And at the time, I was a bit of a zealot for saying that I thought that segmentation descriptions were a distraction and actually stopped people using the data properly. And from a numerical point of view, that was probably correct, in that people came to odd conclusions that the underlying data really didn't support, but they were engaging with the labels. So at the time, I was pushing for a segmentation that had no labels and that just had well, I tried to find as meaningless categorizations as possible. It was a mistake, because first, because nobody uses it, and second, because actually in the end, I now think that actually the labels are almost the most important thing we apply to virtually any data, because that's the thing that gets communicated to other people, and most people outside will ignore the underlying data and will live off the variables, to the extent now that what I'll do is, if I build a segmentation, I will create the numerical element. I'll then endeavor to try and create some labels that I think work. I'll then deliver it to a client and use, and then I'll try and watch the way the client uses the labels, and then try and amend the data to fit the way that the client's using the labels, so that actually that it starts to behave in the way their intuition is running, rather than making, which is inevitably less efficient from a pure data point of view, but I think is more, it more makes the segmentation respond in the way that the users are instinctively using it. So I will. So where does this lead us? And I'll give you just some examples. As I said, this movement between the different worlds creates some confusion, and I'll give you some examples. One of which is that what do we mean when we talk about becoming data literate? And I've seen two books actually just recently with virtually the same title. One was Becoming Data Literate, and the other one was Being Data Literate. But first one, Becoming Data Literate, was written by David, and I forgot his surname. He works with his surname will come back to you. He works with Data IQ.
Dave Reed.
David Reed, of course, yeah, and I was fascinated. I was really keen to read it, and it's an excellent book. But I was coming at it as an analyst, and I was thinking, actually, he's not answering the questions that I want, and he's not doing it in the way that I would describe being data literate, because he never talks about counting and the like. For him, being data literate was the way in which first he looked at the organization, and he looked at how the organization structured itself so that it could handle data. And that and his evidence base for it, which he claimed, was actually more journalistic than a form of structure and tests and numbers. And it made me realize actually what David was doing was actually he was working in those bottom two worlds. As a journalist, clearly he's way more competent than I am at generating the narrative and making the topic engaging. And he was working in that digi space and had very little to say about the numerical element of the three labels. Whereas the other book that I came up was actually all about calculating different numbers, and I have very little to say. In fact, I would say nothing to say about that, the communication element and the psychological elements of the different groups. I'll stop there about that particular one, because the next illustration I think is one of those fascinating ones where insurance companies make actually quite a lot of money out of this particular confusion. They base it on this discussion, and you can give it quite often to lots of people, where you say you've been working with a banker who's female, and then you say to some other people, you've been working with a banker who's female, who's also a feminist, who's an activist in animal health. The illustrations that matter, and you describe the two sets of people, and you ask virtually all humans which of those is most likely. Now, virtually everybody, if you ask them which person is most likely, the person who's a bank teller, or the person who's a bank teller, a woman who's activist, an animal activist and a feminist, nearly everybody will say that the person most likely is the one with the long narrative. And whereas actually the one with the long narrative cannot be more likely than the person with the short narrative, because from a probabilistic sense, they have to be the most common, because the other set is included in the subset. But when you think about the idea that actually most of the time you don't find out just a single thing about a person, you find out a whole range of stuff. Then actually, if you say, what are you most likely to find? You are most likely to find a narrative about a person rather than a single entity. And in the real world, we usually talk about those narratives of individual events, whereas the insurance company can benefit from the fact that it's making a collective decision, and the collective decisions work well with probability. Another illustration is the phrase intelligence. We talked about BI just earlier on this morning, and when I was listening to the latest Reith lecture, and it was about AI, and what happened there was they redefined the definition of intelligence. So intelligence is now a system which adapts to new data to reach its objective, which is definitely a thing that an autonomous thing can do. But actually, surely intelligence, when you ask anybody else, isn't about reaching an objective, it's about choosing the objectives. But they've taken out the choice of objectives and said that's not an element of intelligence. It's another way in which they group it. Another interesting illustration for me is the use of the word experiment. When you ask people in normal language what an experiment is, and my ears have pricked up recently, usually an experiment is something unusual, which is probably what we all agree. But typically in normal parlance, an experiment is when you suck it and see, you don't know what's going to happen, and you allow all sorts of things to happen. And that's what someone would mean when they say they're being experimental. But actually, when you want to learn from numbers and you want to do it in a numerical space, you end up being very rigid about what you're going to do. You predefine what you're going to find, and you actually control very carefully the inputs so that you can make some sensible conclusion at the output. So that very word experiment gets very different meanings if it's in the real world, if you like, or the psychological world, from it being in a numerical world. You've also, and a very simple bugbear that I have is when you hear averages interpreted as a sale in every 3 minutes, for example. Those very obvious perceptions, which I know I've gone into some very senior retail organizations, and they talk about sentences like this, and and even they describe it, that they immediately have in their own mind a distribution that looks a bit like a normal distribution, but actually all you do is show them the distribution of their sales, and it's a decay curve. It's nothing like a normal distribution, yet they're walking in and out of their stores every day and will still focus on that sort of thing. And only recently, one of the other contrasts that I've begun to consider is actually the ease and effort of creating fakes and deceptions in a narrative world, in the psychological sense, in the real world, if you like. It's extremely difficult and it's hard work to maintain a deception. And it's not that people don't try. There's lots of incentives to try, but it's very, very difficult. And to this, I have been quite interested recently in the psychology, which is called the truth default. In that our instinct is to accept what people say to us, and we receive on a day-to-day as the truth and act on it until we see otherwise later down the line. Well, it might turn out that it wasn't sensible, but actually it's a healthy thing to live by and operate if we accept, and if essentially gullible in the real world. But actually, when we go into the numerical world, we know that actually a sense of skepticism is actually the sensible place to start, because actually it is so easy to create, not necessarily deliberately, but accidentally, to create false narratives and bias if you're not careful. And it's the very reason why you run some difficulty if you democratize data too soon. So there's a whole myriad of confusions, and this is why I use the phrase that, and in my thinking about how to write about this, use the working title of "Don't Shoot the Messenger." In that actually, there's all sorts of sources of confusion if you're not careful, and that confusion is what undermines the sense of us being trustworthy. Because as Honora O'Neill says, the first element of being seen as trustworthy is to aim to be trustworthy yourself. Then you've got to try and communicate it. But we have a big challenge because we shift between these different worlds and these different instincts, and hopefully we can become more prepared by it. Not only have we got different instincts and different worlds that we're working in, we've also got different roles at different stages. And I've used various different groupings. For a while, I worked with the idea that to begin with, we have to go into these alien worlds as somewhat like a spy, in that we go there and try and create and identify what's going on without interfering with things. I then talked about the taxi driver and the bugler, but I actually, in conversation with some of yourself, I realised I was actually missing out on a really important element. So the architect is now the equivalent of the spy. As we've already talked about, our role is often to do the feasibility study, to do the initial design and spec of what might happen. That's for me where those ideas of integrity are most important. Where you've got that question of, well, could we? It may be possible, but should we do this? Because we all know that the way in which we frame a problem, because of the fact that the number world is so isolated from anything else, can create solutions which actually lead us in the wrong direction. We've then got to be competent, construct buildings, if you like, that don't fall down, that are consistent. We then have to sell it, and that's in the sense of the communication thing. But and this probably reflects where I sit in what I do, is I'm rarely involved in the maintenance element. In fact, I often tell people that you should keep me well away from operations, because I just frustrate, and because I'm endlessly trying to tinker. I'm trying to remember the football manager, the tinkerer, who constantly got sacked, although he did help Leicester win. But anyway, he was called a tinkerer, and I suspect that's my problem and why I'm rarely involved in operations, and frankly run a mile from it, but I'm not good at it. So not only have we got these different worlds, and those different worlds matter for each of those different elements. It matters when we're being the architect, because you've got to think about how you're going to structure this from a numerical point of view. You know that there's going to be constraints in the digital space and quite how you might find an optimum. And at some point, you're going to have to convince somebody that actually this may be worth doing, or you might decide that it's not worth doing. You've then got to construct those elements and go through a prototyping phase. Again, there's always that need to communicate back to stakeholders. And then once things are set up, there's that process of maintenance, which I'm very pleased about. So what I'm trying to illustrate here is quite why I think our challenge to become trustworthy data analysts is much harder than we might be, and the origin of some of those differences, and fundamentally, and this goes back to what I always say about what's so important about Doug, is that this is why people are still most important, and it's why I think it's a mistake when people constantly talk about, for example, AI replacing humans. They'll often give the example of how they can prove that the AI will have provided a better solution, and they nearly always prove it by using prediction matrices as the metric to prove it. What I counter is that when they're doing that, what they're only ever doing is staying in two worlds. They're not crossing the boundaries. They're either staying purely within the digital world, or they're staying purely within the numerical world, and they're never allowing you to come out and actually sense check whether those solutions are really working and whether they're actually really solving the problem, which is why models which are interpretable and which produce insights which are not just the fact that it's predicted something, but shows you how things interact, are so critical to actually knowing whether a problem is actually being solved. I mean, you all know the story about Google's attempt to predict flu, where they were very keen on and passed this around until they missed the H1N1 flu epidemic purely because it happened in summer, and because what it turned out was that actually the Google methodology was actually predicting autumn and the onset of autumn, not the onset of flu. It just happened to be the case that flu most of the time overlapped. So critical in this is I think that all data analytical solutions should be aware of crossing these boundaries between the numerical world, the digital world, and the social world. And it's only when we can sense check that. And that's really, if you like, where we get that term of the unicorn, if you like, that used to get applied to data scientists, but I think is always the case within the analytics world. And it's where, to go back to the code of practice, and if you like, this whole narrative I've been giving you is trying to give a context in which we see how important the three elements of the code of practice play out. So as I say, the first element, the integrity, I would say is the moral compass that we need. So we need a moral compass, particularly in the creation elements, but of course in the others too, to know that we're doing the right things, and we're doing the right things in ways that are appropriate, and otherwise we get forced into all these privacy regulations, because at some point people went beyond what they ought to have done, and that's created a backlash. The second element is we need a tool set, we need to be competent, and the third set is we need a bugle so we can actually talk about things quickly. And I very helpfully just had a nudge from Jan saying I'm going to run over time if I'm not careful. So I'm going to stop there and say what I'm keen to do is enable analysts to position themselves as this bridge between those different worlds. I'm going to shut up now. Thank you.
Thanks, Tim. Strikes me one important thing is that the complexity of what is truth.
Yes, yeah, that's very true, and how we distinctively approach it.
And if we ever get there,
Well,
in any of our domains, of any aspects of our life, whether we ever get to truth or simply accept truth, a thing as being true or it being true. Anyway, that's
I'm going to shut up because, as you know, I like the sound of my own voice.
Has anybody got any comments to add to Tim's talk, which was quite a complicated talk? Yeah. Yes.
Just on mostly on the confusion slide, but I guess it refers to truth as well, and truth it's only correct if you stop looking deeper, right? There's always another level of truth, so that's sort of the point I suppose I'm trying to make. But so I've written it down, but basically what I want to say was one of the key roles of any analyst is to translate data-driven insight to stakeholders effectively. So in order to do that, we must use an approximation layer, which acts as a translation membrane between the various facets of truth we observed, the communication of insight to stakeholders. So by doing that, we have to, and we are willingly allowing for some of the confusions you've described. It seems to me that the key is that we're doing that knowingly and consciously,
yes,
backing it up with insight, and communicating that it's happening.
No,
that's especially important. Yeah. Sorry, go on.
No, I was agreeing with you. Sorry.
Yeah, I was going to say that's especially important for, say, machine learning and data science, or multivariate analysis for analytical work. So it seems to me then that one of the core enablers to managing these confusions is to communicate that they're inevitable and try to describe the level of risk or approximation required by them existing. So to get a good understanding of the appetite for risk in approximation as part of your contract with your stakeholder, because by their role they are agreeing to make risky decisions based on approximations. So we've got to let them know to what level they're doing that.
Yeah, I would further add that we're making that risk conscious. Lots of people are unwittingly making very risky decisions overconfidently. Sorry, Ian.
Ian, again. You got your hand up?
Yes. So, really interesting talk, Tim, and there's almost too much in there for me to focus on.
Sorry.
But no, it was kind of good. But I suppose some of the things I wrote down lots when you were talking, but some of the things that I sort of came up with is, I suppose, a reflection on what it is to be human and function as a human, and the fact that we try and want to get meaning from something.
Mm-hmm.
Yeah. And actually, the numerical world, and the analytical world, when it works best, gives our clients and ourselves meaning, and insight. But I suppose the other thing that the other very human process that goes on through language is that as a natural process, people use language to abbreviate, to distort, to delete certain content. And actually, one of the things that we can challenge ourselves to do as analysts and keep doing is to be quite rigorous and specific about things. So I think from one of your examples, well, you had several examples, is to see behind numbers or go to the lowest level of detail. So yes, you make a sale every 3 minutes, but you don't really, do you? Some of the time you make no sales in 3 minutes. Sometimes you'll make 10 sales in 3 minutes. And I think that's the other thing that has struck me as I've I guess gotten old and hopefully more experienced, is just trying to think a little more deeply, but a lot more simply, about what goes on in a shop, for instance, that is generating the data and the numbers that I'm seeing.
Yeah. No, thank you. I'm paying the price for rambling on too long. I'm missing out on you.
So and actually the other observation that you or thought that you sparked is that I tend to see things stochastically. So if someone gives me a number, or I see a number, I kind of think, well, that's an expression of a random variable, isn't it?
Yeah.
I think most people don't. I'm generalizing, of course. But there is a big preoccupation, I think, in business to see a number as a number and a definite number. And if someone reports another number as a comparator that is 0.5% difference, then that's a significant difference rather than a stochastic difference.
Yeah.
I think there is another issue, that there are many right ways. There are many ways you can do something correctly.
Yeah, and for me, that I've grown fascinated by the way words can have multiple meanings, and I used to think that was a weakness, but I increasingly think that's a strength, in that you can have a bit of diplomacy where you agree a set of words which you can all agree on, knowing that actually you're all going to interpret it slightly differently. And I actually think and I wish I could find analytics that almost did that to a certain extent, because I think it's a strength to a certain extent. But yeah, I'm going off on one now. I'll shut up. I've run out of time.
I want to add to Ian's bit that I think really what we're doing as analysts is agreeing on our approximations, and that's really where we're getting to at the end of all of this. You might have different approaches, slightly different results, but we have the responsibility to wield our skills to express and agree on those approximations, and then we hold the responsibility to make sure that those that are using those approximations are doing them with the knowledge, or with our knowledge that there is approximation happening.
Yeah, well put,
I have to go, but thank you very, very much.
Thanks, Stevie. Thank you.
Okay, Ian, you had something to say?
Oh yeah, sorry, just briefly, to pick up your point earlier, Tim, on language and clustering and labels and things. So we had a fairly recent project where an analytic team looked to do a store clustering project, and they got I don't know, 100 or so variables together through their agile process, and they did their k-means, and cycled through it, and they found that they got clusters, but they had no way of expressing them what those clusters meant, because they just, you know, they put in 100 dimensions, as opposed to, you know, distilling that 100 down into a smaller number of variables that they could then ascribe meaning to, and then see what they got. And you know, in the end, that project failed, didn't go anywhere, because it couldn't provide meaning.
Yeah, that's right. That is right. Yeah,
Right.
I'm getting told I need to be in some place other than this now, and it's my own fault.
Okay.
So what, as I say, thanks for indulging me for this half an hour, because I'm sort of sense checking my way on how to create a narrative about what being an analyst is, because I want to try and put that into some sort of structure for training about the code of practice. And let's say,
Should we start discussing the next topics for the next meeting?
oh right, yes.
Do you want to lead this, Tim?
I'm not. Just a minute. Let me just tell the other people I'll be with them shortly.
Can we start thinking about topics for next month? Can anybody come forward with some suggestions whilst Tim is clearing his brain?
I'm back in the room.
Okay, Tim, over to you.
I haven't given it any thought yet, as I say, other than I'm now preparing to come around and find people who've got topics around the potential conference. So this framing things around net zero is my focus, and how we can do things that meet short-term net zero gains, so the incremental benefits, if you like, and also those longer-term things that we might need to look at in an organisation.
And our next meeting's on the 12th of May. If I send out an email after Easter to jog everybody's memories about putting
But
someone
actually, thinking about it, one of the things might be is to go back to Ian's second cage rattler, which we didn't really talk about much, and I'll talk to some of my ONS contacts from the various working parties to see what we can do a bit more about releasing some of the data, because linking to your topic about white labeling of open sources, just being a funnel which enables you to white label into a portal that ONS provide, that gives us scope to then access a whole variety of different data sets would help resolve both those things in a sense, wouldn't it? I'll focus something on that for next time as well.
I was looking at global warming, fiddling around for 5 minutes, hunting about stuff, and I came across the most interesting, probably incorrect finding that Australia is the most polluting country in the world if you take the smallness of its population. It's not very industrial. So what's behind this? And apparently it's because they have so many farting cows that are producing global warming gas. Find the reference.
On that note, perhaps I have to go.
Yeah,
Okay.
I've got to go, folks.
All the best, Ian. Thank you.
Very good session. Thank you, everybody.
Pleasure.
Bye.
All the best.